This is Israel, and it has one major problem. More than half of its territory is covered by the Negev desert. It's dry, rocky, lifeless, and really hot. But you didn't really think Israelis would simply accept it that way, did you? They set out to bring the desert back to life. First, Israel attempted what seemed impossible. Right here, in the middle of this barren landscape, a forest appeared. Millions of trees breathing life into a territory where almost nothing could survive. But the idea wasn't nearly as successful as it first appeared. In the end, the trees actually made things worse. Still, the country didn't give up. Beneath their feet, Israelis discovered something that could completely transform the Negev. And to make it work properly, they added one small but crucial detail. Today, this lifeless land is being revived by something that, according to every law of nature, shouldn't be able to exist here at all. And today, I'm going to tell you what the Israelis came up with and why it represents nothing less than a revolution for a desert nation. To understand how this story began, let's go back to the 1960s. You're looking at the vast, sun-scorched expanse of the Negev desert. People come up with a plan that sounds like a daring gamble today, but at the time seemed like the only logical solution. The Israelis decided to plant a forest, a real, enormous forest right on the edge of the lifeless wasteland. That was how the legendary Yatir Forest Project began. The logic behind the decision seemed perfectly clear. The desert was constantly advancing, so the country needed a powerful natural barrier. The project's architects had a simple idea. Millions of trees would lock the shifting soil in place with their roots, stop destructive dust storms, and help retain precious moisture. Most importantly, the spreading green canopies were supposed to act like a gigantic sunshade. They would shield the pale ground from the scorching sun, bring cooler temperatures, and radically change the local climate, transforming the barren landscape into a thriving oasis. In the end, people planted more than 4 million saplings across an area of over 11.6 square miles. And at first, the project really did work. The trees took root, grew to full height, and formed the largest man-made forest in the entire country. Yatir became a source of national pride and proof that human ingenuity could tame even the most unforgiving wilderness. For years, Israel considered expanding the forest, believing that it could bring even more of the Negev back to life. Unfortunately, however, Yatir Forest was never destined to become the large-scale solution the country had hoped for. The first thing that brought the project to a halt was basic physics, or more specifically, something called albedo. Here's how it works. The pale surface of the desert acts like a gigantic mirror. It can reflect up to 40% of the sunlight that hits it straight back into space. The dark needles of the trees do exactly the opposite. They greedily absorb the sun's rays, turning the enormous forest into a scorching heat sink that warms the surrounding air even more than the desert ground does. But this radiator effect is only the tip of the iceberg. Yatir Forest has ended up in a severe ecological dead end. In the relentless heat, the coniferous trees, which make up most of Yatir Forest, suffer from a catastrophic lack of moisture. To avoid simply dying of dehydration, the pines close the pores in their needles and stop releasing water vapor altogether. That means the natural cooling effect the entire project was meant to create simply shuts down. The trees spend years under constant stress. Their crowns become thin, ragged, and sparse. As a result, the weakened pines have become easy prey for insects. Swarms of bark beetles have invaded the forest, literally eating their way through the trunks while the trees are still alive. On top of that, every summer the parched forest turns into a dangerous powder keg where recurring wildfires can wipe out large areas almost instantly. Instead of a thriving oasis, the country ended up with a sickly mass of trees that cost millions of dollars every year to keep alive artificially. Expanding the forest to green the rest of the Negev was clearly out of the question, but the Israelis didn't give up. Instead, they looked beneath their feet and discovered something that offered new hope for bringing the desert to life. In the 1970s, wells were drilled across the Negev in search of any possible source of drinking water. Nearly 0.6 miles underground, massive drill bits finally broke through the dry rock and brought precious water to the surface. It turned out that an enormous aquifer lay directly beneath the scorching desert. Put simply, it was a prehistoric ocean trapped inside layers of rock since the Ice Age. Imagine the researchers' excitement. Billions of cubic feet of water right beneath their feet. All they had to do was pump it out and bring the entire south of the country to life. But when the thrilled scientists finally analyzed the samples in a lab, their excitement turned into bitter disappointment. The discovery was geothermal water heated underground to around 104 degrees Fahrenheit and loaded with high concentrations of salt. You obviously couldn't give people hot, salty mineral water to drink, and it couldn't be used to irrigate ordinary fields either. The salt would quickly burn the roots and turn the already dry soil into a lifeless crust. That was when the Israelis had an idea to run the water through machines like these. These are desalination plants, and in Israel, desalination had already become something of a way of life. Even then, the country was emerging as the undisputed global leader in desalination. Today, enormous plants along the coast supply more than 80% of the drinking water used in Israeli homes. So why not build a few more plants in the Negev and use them to bring the desert to life? Here's why. Simply pumping all that water up from more than 3,000 feet underground would require an enormous amount of electricity. And that was only the beginning. The water, heated to nearly 104 degrees Fahrenheit and loaded with an extreme concentration of minerals, would then have to be forced through incredibly fine membranes under tremendous pressure. Under normal conditions, these filters can last for years, but the hot, highly corrosive solution drawn from ancient underground layers clogged and destroyed them in a matter of weeks. The biggest obstacle, however, was the environmental and infrastructure challenge. Powering such energy-hungry facilities in the middle of the dunes would require hundreds of miles of high-capacity transmission lines. And what could they do with the highly concentrated brine left behind after filtration? On the coast, it can be discharged back into the sea. In the middle of the desert, that caustic brine would quickly turn the surrounding land into a lifeless white wasteland. As a result, the cost of producing this desert water climbed to astronomical levels. It was several times cheaper to desalinate ordinary Mediterranean seawater at coastal plants and pump it through pipelines across the country than to build absurdly expensive facilities directly above the desert wells. So did Israel have to leave the water underground and wait for better, more advanced technology? No. Instead, it found creatures that could thrive even in this difficult water. The choice came down to two highly valuable fish species, heat-loving tilapia and Australian barramundi. When researchers conducted a detailed chemical analysis of the groundwater from the Negev wells, they were stunned. The unique balance of salts, magnesium, and calcium in this prehistoric aquifer turned out to be perfectly suited to these fish. The conditions were perfect for fish farming, but one major problem still stood in the way. Water rising from the deep underground layers was far too hot. They couldn't simply fill a pool with it and release the fish. The animals would die. But the Israelis found a solution to that problem as well. Right in the middle of the scorching desert, surrounded by sand dunes, enormous covered facilities and strange hangar-like buildings began rising from the ground. And if we could take a look inside, we'd find a highly advanced system at work. First, powerful deep well pumps draw hot water from more than 3,000 feet underground and bring it to the surface. Before the water reaches the fish, it passes through special cooling units where it releases its excess heat. Once cooled to a comfortable temperature, the water is pumped into the fish tanks. Now, fish swim around, eat, and naturally produce a huge amount of waste. Under normal conditions, a tank like this would quickly turn into an uninhabitable swamp. But this is Israel we're talking about, and the country knows exactly what it's doing. The tanks use a continuous circulation system, so the water never sits still for even a second. The constant current immediately picks up waste from the bottom and carries it out of the tanks and straight into the treatment area. There, the water first rushes through special filters that capture scales, suspended particles, and uneaten feed as it passes. The water may now look clear, but it still contains substances that are dangerous to the fish. So next, it flows through the colonies of billions of beneficial bacteria. These microscopic helpers literally consume the dissolved waste and convert it into harmless compounds. All that remains is to enrich the water with fresh oxygen, and it's ready to return to the tanks. Another major advantage is the composition of this ancient underground water. The naturally occurring salt acts as a powerful protective barrier, killing dangerous microbes and parasites. The fish don't need any medication at all. The result is a nearly perfect closed-loop system. The water in the tanks is constantly moving and being purified, creating conditions that are more like a luxury resort for fish. No dust, no disease, and no antibiotics. In this environment, the fish grow at an incredible rate, while Israelis produce tons of premium seafood right in the middle of the desert. But the most impressive part begins when some of the water needs to be replaced. No one even considers throwing the used water away. It's sent out to help bring the Negev desert back to life. While the tilapia and barramundi swim inside these closed-loop facilities, they enrich the water with plenty of natural organic matter, nitrogen, phosphorus, and nutrient-rich sediment. What comes out is essentially a perfect 100% natural liquid fertilizer. This enriched water is then carried through drip irrigation lines directly to the roots of salt-tolerant plants, and that's where the real agricultural magic happens. The powerful flow of nutrients gives the crop such an enormous boost that they can thrive and produce remarkable harvests even in salty soil. And these aren't experimental concepts, they're fully operational commercial farms. Take jojoba, for example. Israelis have planted large areas of the desert with this hardy shrub. It thrives in extreme heat, while its powerful root system anchors the sand and helps prevent further desertification. As a result, the Negev alone now produces around 50% of the world's high-quality jojoba oil. This liquid gold is purchased by the ton by some of the biggest companies in the global cosmetics industry. Nearby, medjool date palms grow on the same land. Date palms tolerate salinity extremely well, and the nutrient-rich water produces such vigorous growth that the fruit becomes exceptionally large and sweet. Today, enormous quantities of these premium dates are exported from the region to markets around the world. But the most surprising breakthrough came when farmers tried irrigating vineyards with the used saline water. A small amount of salt places the vines under controlled stress. The plant essentially thinks it's dying and channels every last bit of energy into its fruit. The grapes grow smaller and develop thicker skins, but the juice inside becomes far more concentrated and intense. So intense, in fact, that Israeli desert wines have begun competing with traditional wineries and winning top honors at prestigious international competitions in France and Italy. In the end, every gallon of water pumped from deep underground is used to its fullest potential. First, fish grow in it. Then, every last drop is delivered to the dry soil, literally bringing the Negev desert back to life. Sounds perfect, doesn't it? Unfortunately, it's not quite that simple. These systems are isolated, highly advanced technological hubs. There are several facilities in the Negev that pump ancient geothermal water from underground, use it to raise fish, and then reuse it to grow crops. But that hardly seems sufficient to bring an entire desert to life, does it? For Israel, though, that's enough. After all, it's bringing its desert to life not only with underground water, but also with waste that would normally be thrown away. Every morning, millions of people brush their teeth, take a shower, and flush the toilet. In most countries, these enormous volumes of sewage are treated as nothing more than dirty waste. They usually undergo only basic treatment before being discharged into rivers or the ocean. But when more than half of your country is dry, barren land, you tend to see things differently. Israelis looked at their city's wastewater and decided that dumping so much water into the sea was a luxury they simply couldn't afford. So they built a system unlike anything else in the world. These statistics are enough to impress even the skeptics. Today, Israel treats and reuses around 90% of all its domestic wastewater. To put that into perspective, Spain, which ranks second in the world, reuses only about 20%. Most developed countries barely manage to recycle 5% to 10%. The driving force behind this system is the massive Shafdan wastewater treatment facility outside Tel Aviv. Sewage from the country's largest metropolitan area flows into the complex, where it's transformed into reclaimed water. It isn't suitable for drinking, but it can be used to bring the desert back to life. This reclaimed water is pumped through a separate network of major pipelines for dozens of miles south directly into the scorching Negev desert. That's where it does its most important work. It irrigates vast cotton fields, fruit orchards, and vegetable farms. As a result, more than half of all agriculture in the Negev now relies not on drinking water or rare rainfall, but on treated wastewater that once flowed out of the homes of Tel Aviv residents. And that made me wonder, where does Israel get the energy for everything it does in the Negev? Pumping and distributing water takes energy. Aquaculture farms supplied with geothermal water also require energy, and quite a lot of it. The answer is actually pretty simple. The Negev gets more than 300 days of sunshine a year, and Israel decided to channel that enormous flow of solar energy right into the power grid. One of the most striking symbols of this transformation is the Ashalim power station, built right in the middle of the desert. At its center stands an 853-foot solar tower, one of the tallest structures of its kind in the world. Surrounding it is an enormous field of 50,000 computerized mirrors stretching for miles. Each mirror tracks the sun with extreme precision and focuses its rays onto the top of the tower, heating the thermal fluid to more than 930 degrees Fahrenheit. From a distance, the tower glows like a second sun. But inside, the process is based on simple physics. Superheated steam under tremendous pressure spins turbines and generates electricity. Engineers also address solar power's biggest weakness, the lack of sunlight at night. The complex uses tanks of molten salt to store heat collected during the day, allowing the generators to keep running for several hours after sunset. In addition to the tower, enormous fields of conventional photovoltaic panels have been built throughout the Negev, along with systems that perform two jobs at once. These are floating solar power plants installed right on the surface of reservoirs. To store all that reclaimed water, dozens of enormous open-air reservoirs have been constructed across the Negev, but in the middle of a dry desert, these pools face a serious problem. The blazing sun quickly heats the water, causing huge quantities of precious moisture to evaporate into the atmosphere and simply disappear. Israeli engineers found a way to solve two problems at once. On the one hand, the blanket of solar panels acts as a giant shield. It protects the water from the intense sunlight, reducing evaporation to almost zero and preserving every possible gallon. On the other hand, the water beneath the panels continuously cools them. In temperatures approaching 122 degrees Fahrenheit, ordinary solar panels can overheat badly and lose efficiency, and constant cooling from the water allows the floating panels to operate closer to peak performance and generate as much electricity as possible. Together, this solar network produces a powerful stream of clean energy, which powers the pumps that carry reclaimed water from Shafton, bring geothermal water up from the depths of more than half a mile, and supply electricity to enclosed aquaculture farms. The desert has effectively closed the loop. The relentless Negev sun itself provides the energy needed to pump water and make the dry sands bloom. So Israel's clearly a resource-conscious and technologically advanced country, trying to bring the Negev to life in every possible way. But every one of those methods requires electricity. Here's the interesting question, though. What would happen if Israel needed far less energy to bring the desert back to life? Because that is entirely possible. Scientists at Israel's Volcani Institute have learned how to grow desert truffles in the Negev. This underground fungus was once considered notoriously difficult to cultivate, but researchers managed to domesticate it, making barren sand support real life with minimal resources. The key to the method is based on pure biology, with very little electricity required. Scientists take an unassuming desert shrub known as rock rose and introduce truffle fungi to its roots. Once planted in dry soil, the two form a strong symbiotic relationship. The shrub supplies the fungus with carbohydrates, while the expanding fungal network draws tiny amounts of moisture and valuable minerals from even the driest layers of soil and delivers them to the plant. As a result, stable vegetation begins to grow where there was once nothing but scorched earth, while a complete underground ecosystem develops beneath it. There are no enormous solar towers, sophisticated automated systems, or powerful deep water pumps. All that's needed from humans is basic drip irrigation to help the shrubs become established. And as a welcome bonus, a valuable delicacy ripens beneath the bushes, one that restaurants are willing to pay handsomely for. The Israelis have found a simple way to populate the desert with useful plants and organic matter without placing any significant burden on the power grid. But could another country match Israel's success in bringing the desert to life? Yes, and that country is Australia. Just look at what they've created there. This is the Sundrop Farms complex hidden in the scorched desert near Port Augusta in South Australia. Its creators managed to establish a massive tomato growing operation in a place where even weeds struggle to survive, while completely abandoning both freshwater aquifers and the municipal power grid. Instead, they laid a 3.1-mile pipeline directly to the Spencer Gulf and began pumping in enormous volumes of seawater. Then the real engineering madness begins. Rising from the middle of an empty expanse of sand is a 377-foot solar tower surrounded by 23,000 computer-controlled mirrors. The system captures the blazing sunlight and focuses it on the top of the tower, producing steam at extremely high temperatures. The resulting heat solves three major problems at once. First, it powers the desalination of seawater, producing millions of gallons of clean, fresh water. Second, the heat drives turbines that generate the facility's own electricity. Third, untreated seawater is used to cool and humidify the air inside nearly 49 acres of enormous greenhouses. When outside temperatures climb above 104 degrees Fahrenheit, damp cardboard cooling pads bring the temperature inside the greenhouses down to a comfortable level. Meanwhile, the salt in the seawater helps suppress bacteria and pests. That's why chemical pesticides aren't needed there at all. The tomato plants themselves are not grown in the poor local sand. Instead, they're planted in specialized hydroponic trays filled with an organic growing medium made from coconut fiber. An automated system delivers desalinated water and nutrients directly to the roots through drip irrigation, conserving every possible drop. Essentially, the Australians harvest around 17,000 tons of juicy tomatoes every year from a completely scorched piece of land with no freshwater sources. That's an astonishing 15% of the country's entire tomato market, produced using only sunlight and ordinary seawater without fossil fuels or groundwater wells. But growing tomatoes is one thing. Turning the desert into a luxury resort for fish, as Israel does, is quite another. And Israel isn't the only country doing it. It has company. Now let's head to the United States, to Arizona's scorching Sonoran Desert. Here, Americans have somehow managed to raise genuine Pacific white shrimp right in the middle of the dry, sandy landscape. The secret is that deep underground, just like the Israelis, they discovered layers of brackish water. It isn't safe to drink and is too salty for most crops, but it turned out to be perfect for saltwater shrimp. Once the water's done its job in the shrimp ponds, now enriched with organic waste, it's redirected to irrigate nearby cotton fields. No complicated systems and no unnecessary expense. While Arizona simply worked with what nature had hidden underground, the Chinese turned the edge of the Taklamakan Desert into the stage for an extraordinary scientific experiment. In Xinjiang, thousands of miles from the nearest coastline, Chinese researchers took unusable saline water and deliberately rebuilt its chemical composition. Scientists painstakingly calculated the correct balance of trace elements, added the necessary salts, and effectively created fully functioning seawater in the middle of the scorching sand dunes. Today, this desert ocean produces tons of shrimp, crab, sea bass, and even salmon, a species highly sensitive to water quality. To prevent water loss in the arid climate, the Chinese enclosed the pools inside advanced recirculating aquaculture facilities. Specialized biofilters continuously remove waste products from the water, allowing more than 90% of it to circulate through a closed-loop system for years. The United Arab Emirates, however, have taken the idea to an almost absurd technological extreme. In the middle of the blazing desert near Dubai, they've built an ultra-modern aquaculture complex that raises Atlantic salmon. In the wild, this fish normally lives in the icy ocean waters and fjords of Norway. Just consider the contrast. While temperatures outside climb above 113 degrees Fahrenheit and the asphalt begins to melt, the water inside the enclosed tanks is kept at a steady 55 degrees Fahrenheit. The powerful automated system doesn't merely cool and filter the water. It creates artificial ocean currents, adjusts the lighting to simulate polar days and nights, and even reproduces the rhythms of the tides, encouraging the salmon to swim actively and gain weight. As a result, the Emiratis can produce perfectly fresh salmon right in the desert without burning hundreds of tons of aviation fuel to fly frozen fish in from the other side of the world. So one thing can be said with confidence: Israel isn't the only country capable of mastering the desert. In many parts of the world, it's no longer treated as a hostile wasteland, but as a canvas transformed by species that were never meant to thrive there.